Hey guys, I got my 1968 Princeton Reverb Silverface here. Bought it about 7 years ago from a pawn shop. Couldn't believe how original and clean it was. Faceplate's a little bit rough, but certainly nothing that isn't to be expected in an amp this old. The original foot switch, all the original transformers. All I've ever done to this amp, other than play it, is to replace the 2-prong cord with a 3-prong grounded cord, and I did remove the death capacitor. I was playing it about 2 weeks ago and just really jamming when the wife was gone, and I noticed that every time I hit a real loud power chord or something, strum really hard, the indicator light would dim just a little bit. And that got to me to thinking, you know, I tested all the capacitors and everything when it was new to me. And I thought it sounded great and the voltages were good. But, you know, I turned 52 this year. This amp came out when I was 2. So that means those caps in there are 50 years old. And even though some people think you need to keep these things original, I want this thing to be working for years in the future. So I am going to pull it apart. We can take a look inside the chassis, see what a beautiful, pristine 68 Princeton Reverb Silverface looks like, and then I'm going to replace the caps, and we'll see if maybe that transformer issue has gone away. One thing I will mention, I did say that it was 100% original, and it was. This Patriot Eminence Copperhead speaker I replaced. The original is up there on a shelf, boxed away in the box that the Patriot came in. But I really just wanted to make sure that I didn't ruin the speaker, and so I put it away. I love the sound of this speaker. It's wonderful. And here in a minute I'm going to grab the camera and we'll walk through a little bit more closely, showing you guys what it looks like close up. Okay, as I said, I did replace the cord, and I didn't want to drill anything, and I know that's a real cheesy way to hold the cable in, but that's the way I chose to do it. So anyway, the ground switch has been disconnected. As you can see, the original speaker plug has a bakelite connector on it, but that is not, that's up with the original speaker in the same box. The reverb cables are a little bit rough, but sound fine and measure fine. That looks like some electrical tape was used on the reverb pedal plug, but that is, again, original. I could lose a few, inches off of that cable and redo that if I ever felt like it. There's a shot of the tube chart. It's been a little bit ripped up, and it is kind of coming loose. If you look at it, you can see that it's coming loose, but that's not the end of the world. I'll tape that down, or not tape, I'll glue that down a little bit. There's the Reverb Tank, which sounds fantastic. I did just get a cover for this amp, so I am going to pull everything out and clean it up and shine it up, and then put the cover back on. I did buy a new GZ34 rectifier. Don't even know why. And then these are two NOS, I think GE tubes that I had from my dad's stash. My dad, very big into amateur radio, and I inherited about 3,000 tubes from him. And some of those were those nice 6v6s. And let's see. Yep, I pretty much think I took the back cover off. There's the back cover right over there. So it's all good. Let's pull this thing out and look at it, and then we'll order some parts, and then we'll pop them in and see how it sounds. So there it is after I've gutted the chassis out of it. And here she is. Got my schematic, got my layout, so I don't have to constantly spin things to find out what they are. And there she is, 100% original, except for the 3-prong power cord, which I did a long time ago. And what are we going to do? As you can see there, the date 12/68. This is a late 1968 Princeton Silverface Reverb. We're going to replace the bias circuitry, most of it anyway. I don't know about the diode. We're going to clean all the pots. We're going to replace these molded capacitors. We're going to check all the resistors. We're going to replace that can capacitor. And then we're going to, after we do that, check all of our voltages and button it back up. Like I said, the problem that I experienced earlier, by the way, that ground switch has been disconnected and the death cap has been removed. That did happen also. I forgot about that. So basically the thing I was experiencing was that kind of extreme sagging. So something makes me think that as much as I love having all the original components in there, I'm going to save them all in case some geek later wants to see them. But yeah, they're mostly going to be replaced. So that's what I'm going to do right now, is go make a shopping list up and then probably give it a week, and next weekend make all the changes. Okay. So I started replacing everything. I replaced the bias components except for that diode there. Let me get that out of the way. That all went together just fine. And then I started over here, started working my way across, checking all the components as I did. And then I realized that I had made a slight error. And that is, when you get to these old resistors, capacitors, I wasn't thinking that this is actually 2. As you can see, they have a common negative, but there's multiple 2 in there. There's 225/25s in there. So that meant I had ordered the wrong amount. So I went and changed my order up a little bit. I think I ordered just a few more too, just in case the tremolo circuit needed some work. And one thing I would recommend is when you get to these things here, you really need to have a big honking soldering iron to heat. Otherwise the chassis just sucks up all the heat and you don't end up getting a good connection to ground there. So I went ahead and ordered another larger one. Let's see, and this is the old, these are the old caps that I'm going to go ahead and hold on to. And let's see. So we're moving right along. I think one thing I did run into here, and I want to show you guys, this is something to think of if you recap one of these. See this right here? This is extremely crowded. And you look at these old resistors, and they've got fairly large leads on them. And so I've really been struggling to get these in there once I get the capacitors in there. See this one is just ugly. It's really tight in there. So I think what I'm going to do is I'm going to replace with some of these newer resistors that I have over here. They have much smaller leads, and even though there's nothing wrong with these resistors, I think I am going to go ahead and replace them. Since I'm sure I have those values, they're fairly common values. And then at least the leads will be a little bit smaller. And but other than that, everything's coming together nicely. I'm going to go ahead and clean all the pots and the tube sockets and tighten up everything and probably polish that back plate before I button it all back up. All right, I'm back. So what I've done so far, I used the big soldering iron to make sure that I soldered those ground connections really well on that can cap. I went ahead and replaced this resistor. I bought some 3-watt resistors for these, even though they measured fine. They looked like they had been heated up a little bit. So changed those. So as long as I was at it, I went ahead and put that 3-watt resistor in there. It's a little more than it requires on the schematic, but more is better. This is one of the ones that I had neglected to buy the first time. So there's a 600 volt, 0.1 microfarad, 0.1 microfarad, 400 volt. That's just because I bought them at different times and they were out of these. And then I don't know if you can see, but what I did here was I ended up having to stagger these because, believe it or not, these 1-watt resistors I bought, were barely long enough to fit between these two eyelets on the eyelet board. So I staggered this and ended up having to tie this one off so that those grounds, or rather those negatives, are soldered together, and that with those two smaller leads allowed me to get everything in there. It's still a real tight fit. Everything else I already talked about. I cleaned the tube sockets, I cleaned all the pots, I sort of cleaned, not as well as I'd like, the knobs. And so now I've got a dummy load here going back to a 20 watt 8 ohm resistor just sitting there. And what we're going to do now is we're going to bring it up on the variac, which is off here to the right, and we're going to start checking voltages. I have all the voltages that I measured from before, as long as what I was gonna, or as well as what I was gonna replace. And what I'm gonna do is measure these voltages and see where we come up with the new capacitors. Okay, so I couldn't read my little readout on my variac, so I moved it up, propped it up a little bit, and right now we're at 48 volts going into the amplifier. We're pulling 0.16 amps. Nothing seems to be ugly right now. We're going to move it up to 55, and we start to see the jewel lamp come on, and we are at 60 volts, 59 actually. Let's measure the voltage at the top of the bias. Make sure we're getting something. Negative 17 volts so far on the bias, and that's, like I said, at 59 volts. So we are seeing bias voltage. That's good. Before I take it up anymore, I wanted to make sure of that. So why don't we just bring it up a little bit more here. Bring it up to about 90 or 84.6, since that's where it landed. And we'll make sure we're still getting increasing negative voltage. Minus 25. Ultimately what we're shooting for here is minus 35. 33 is what I measured before. So I think we're in good shape there. So far that's looking really good. So I'm not seeing any smoke or anything, so why don't we go ahead and bring it up to line voltage here. That's 119. That's what I'm going to be running it at most of the time anyway. So let's see how much current we're drawing. Half a watt, or half an amp rather. 0.6 actually. Okay. Looks like our bias voltage is settling down at 35.6. Like I said, schematic calls for minus 35 based on this line voltage probably being more like 115 or 110. So we're in good shape there. Let's measure these nodes at the B plus, going off to the B plus here on the can caps. So let's see here. The first one is the square, which was reading 430 volts. So let's see what that's reading now. If I can get that on there without 432. The triangle was 340. That's got a resistor on it. It's now 337. The unmarked was 257. It's now 256.7, so that looks like it's bang on. And let's see, how about we measure some plate and or screen voltage. Screen voltage going into the number 4 pins should be tied together, and that was 425 volts. So let's see here, where's the key? 1, 2, 3, 4. Well, it would help if I could get that on there without shaking. 420, and before it was 425, looks like. So our screen voltage has come down a little bit, and our plate voltage, 1, 2, 3. Plate voltage going off onto that 427, was 424 before, and the other one, 1, 2, 3, there we go. I should just get out some actual probes instead of these clips, but 428, 427, okay. So, as far as I'm concerned, everything checks out. And remember, the initial problem with this thing, in my opinion, was, like I said, the light would kind of dim when you would first fire it up. And I didn't like that. That's interesting. On the plate V1 here, the 7025, which is actually just a 12AX7, was 180, and it's now down to 170, so that's a decent amount of change. And the second part of it, which would be what, pin 6, I believe, I hope. 1, 2, 3, 4, 5, 6. Jeez, Ross, slow down. All right. I'm going to end up blowing something up. Alright, I can't seem to touch that without shaking too much because I had too much coffee. So, anyway, so far it's looking just fine. Can't think of anything else that I need to check right now. Let's make sure that bias voltage is staying nice and negative at about 35. Minus 35.8. Alright guys, I think this thing is ready to be buttoned back up and put into test. Alright, here it is, all fired up, ready to go. I'm going to be playing Made in Mexico Strat through it, straight in. Normally I use a compressor and some delay, maybe. But today I'm just going to be going straight into it. Obviously I have it mic'd up with an SM57. And when I really hit some of these power chords really hard, the jewel, the little pilot light, was really dimming. And now you don't notice it even a little bit. So that tells me that whatever it was most likely those capacitors, those old capacitors were, when they would drain, requiring a little bit too much current from the power transformer and causing it overall to dip. Definitely something you hear about these Princeton reverbs is that their transformers weren't quite up to snuff. So anyway, let's go ahead and play a little bit. as you can see, that jewel pilot light didn't dim even in the slightest. And the one thing I kind of regret, if you notice, the tremolo intensity was up to 8. And you notice it, but it's still not as pronounced as I seem to recall. So maybe when I was in there, I should have replaced those, probably another $5 worth of parts. So anyway, maybe I'll do that later, but for right now I can live with it. And I think I was all in about $50 is all I ended up spending in parts, and maybe all told about 2 hours worth of soldering. So if you guys have one of these things and you want to keep it super original, just do be careful and look out for things like that. You don't want to blow up your transformer just because you wanted to keep $50 worth of capacitors nice and pristine.